In this video lecture, we will discuss the pH, pOH and pKw. Why the pH scale was developed? What is the reason why we are using the pH scale? Knowing the concentration of hydrogen ion is one of the greatest importance in chemistry. The concentration of hydrogen ion and hydroxide ion in aqueous solution are very small numbers. Just like 10 raised to power minus 2, 10 raised to power minus 12, 10 raised to power minus 7. So it is difficult to work with these small numbers like 10 raised to power minus 14, minus 12, minus 7. So while writing these numbers, there occur a mistake in writing it. So in order to convert this small number into a sum number or into a whole number, we will use the pH scale. And the pH scale was developed in order to convert this small number into a whole number. pH scale, a Danish chemist Søren Sørensen in 1909 proposed a more practical measure of expressing the concentration of hydrogen ion and hydroxide ion in terms of pH. This scale provides a simple, convenient numerical way to state the acidity of solution. Now, what is pH scale? It is defined as the negative logarithm of the hydrogen ion concentration or the activity of hydrogen ion in aqueous solution. Mathematically, it is expressed as pH is equal to minus log of concentration of hydrogen ion, or we can say pH is equal to minus log of concentration of hydronium ion, where hydrogen ion is the concentration of hydrogen ion that is taken in mole per dm cube or molar. Alternative and more useful form of the pH definition is pH is equal to log 1 divided by hydrogen ion. When it will move to the numerator side, we will take the minus log. So this formula will be evolved. So pH is equal to log 1 by hydrogen ion concentration and pH is equal to minus log hydrogen ion concentration. Both are taken as same. For pure water or neutral solution at 25 degrees C, hydrogen ion concentration is equal to 1 into 10 raised to power minus 7 moles or moles per dm cube. So the pH in this case will be equal to pH is equal to minus log of hydrogen ion concentration. The hydrogen ion concentration given is 1 into 10 raised to power minus 7 moles per dm cube. So we will take the minus log of it. Minus log of 10 raised to power minus 7, it is equal to 7 at 25 degrees C. So we know that the pH will 7 for neutral solution. If the pH is less than 7, the solution will be acidic, and the pH will be greater than 7, then solution will be basic. Also, we can calculate the hydrogen ion concentration from pH. If we know the pH of the solution, we can calculate the hydrogen ion concentration by taking the anti-log of pH. So the formula is hydrogen ion concentration is equal to anti-log minus pH, or hydrogen ion concentration is equal to anti-log, this is the term for anti-log, minus pH. Now how this formula is evolved? pH is equal to minus log of hydrogen ion. So we will take it to the right side in order to make it inconvenient, and pH will be taken to the left side. So pH minus log of hydrogen ion is equal to pH. Both are same formula, but for convenience we have shifted the minus log before and the pH after it. So minus will shift to the other side. Multiply both sides by the minus, so minus will result plus. Here it will become minus. So log of hydrogen ion is equal to minus pH. Now shift the log to the other side because we are finding the hydrogen ion concentration. So we will shift the log to the other side by taking anti-log. Hydrogen ion concentration is equal to anti-log, and here the minus is taken as such and the pH will be taken as such. So by taking the anti-log minus pH, we can find the hydrogen ion concentration of any solution. The same logarithm expression, just like pH, is used to indicate the hydroxide ion concentration, and that is known as pOH. So the pOH is defined as the negative logarithm of the hydroxide ion concentration. pOH is equal to minus log of concentration of hydroxide ion. Now a solution at 25 degrees C has hydroxide ion concentration. It is equal to 10 to the power minus 7 molar or moles per dm cube. Now find the pOH, that is equal to minus log of hydroxide ion. So the minus log of 10 to the power minus 7, it will result in 7. 7 is the pOH of a solution at 25 degrees C. Calculation of OH ion, hydroxide ion from pOH. Just like pH and H ion, the OH ion concentration can be calculated from pOH by taking the anti-log of pOH. So the hydroxide ion concentration, it is equal to anti-log minus pOH, or we can write it as hydroxide ion is equal to anti-log pOH. This will show a summarized conversion of pH ion into OH ion, hydroxide ion into pOH ion. Alternately, it is converted again to the hydroxide ion, pH and pOH interconversion, and pH and hydrogen ion interconversion. Now starting from pH, pH can be converted to the hydrogen ion using the formula hydrogen ion is equal to anti-log minus pH. Similarly, the hydrogen ion can be converted to pH using formula pH is equal to minus log of hydrogen ion. Similarly, OH, hydroxide ion, can be converted to pOH using formula pOH is equal to minus log of hydroxide ion. In a similar way, pOH can be converted to hydroxide ion using formula pOH is equal to anti-log minus pOH. Similarly, pH and pOH can also be interconverted to each other using formula pH plus pOH is equal to 14. So by alternating shifting the pH and pOH to the other side of equation, we can find the pOH and pH both. Similarly, hydrogen ion can be converted to the hydroxide ion using formula OH, hydroxide ion, is equal to 10 to the power minus 14, that is the value of Kw, divided by hydrogen ion. And the hydroxide ion can be converted to the hydrogen ion using formula hydrogen ion is equal to 10 to the power minus 14 divided by hydroxide ion. In pure water, a hydrogen ion concentration is equal to the hydroxide ion concentration, and both are equal to 10 raised to power minus 7 moles per liter or moles per dm cube, or we can say molar. So water is therefore neutral and its pH is 7. So the hydrogen ion is equal to the hydroxide ion, and both are equal to 10 raised to power minus 7 molar. So the pH of solution will be equal to 7 and it will be neutral. So it is in this region, pH 7. The hydrogen ion and hydroxide ion both are 10 raised to power minus 7. If the water is made acidic, acidic means the hydrogen ion concentration will increase as compared to hydroxide ion, because the hydrogen ion will represent the acidity and we are making the water acidic, so which means that hydrogen ion will be more than hydroxide ion, and the hydrogen ion concentration will be more than 10 to the power minus 7 molar. So which means that it is equal to 10 to the power minus 6, minus 5, minus 4, minus 3. All these terms are greater than 10 to the power minus 7. So the pH alternately will be less than 10 to the power, will be less than 7. So pH 6, 5, 4, 3, 2, 1, these will results from 10 to the power minus 6, minus 5 and so on. which means that the hydrogen ion concentration will be greater than 10 to the power minus 7 and the pH will be less than 7. The solution will be acidic. Alternately, if the solution is made basic is actually the hydroxide ion concentration, which means that hydrogen ion will be less than hydroxide ion, or we can say the hydroxide ion will be greater than hydrogen ion. And the hydrogen ion concentration will be less than 10 to the power minus 7 molar. So 10 to the power minus 7 molar is here. So all these blue area will represent the hydrogen ion concentration that is less than 10 to the power minus 7. And the pH value from this table, if you look at this table, the pH value will be greater than 7, 8, 9, 10, 11, 12. So pH value will be greater than 7 for basic solution. The last term is pKw. Just like pH and pOH, pKw can be defined as the negative logarithm of Kw, that is the ionization constant for water, and it can be written as pKw is equal to minus log of Kw. We know that hydrogen ion concentration into hydroxide ion concentration, it is equal to Kw. Now how this formula is evolved? If we take the water and its auto-ionization, so the water will ionize and it will produce the hydrogen ion and the hydroxide ion. The extent of ionization in this case is very low, which means that the hydrogen ion and the hydroxide ion will produce in a less amount as compared to H2O, which means that H2O will present in large excess. So by taking the equilibrium constant, that is Kc is equal to ionized portion divided by unionized portion. So the hydrogen ion and the hydroxide ion, these are the ionized water molecule divided by the unionized water molecule. We know that the H2O water is unionized water is in large excess and its concentration will remains the constant. So putting this constant term into the other side of the equation with equilibrium constant, so Kc multiplied by concentration of water, it is equal to the hydrogen ion concentration into hydroxide ion concentration. Now multiplying both constant, and it will result in a single constant, that is Kw is equal to hydrogen ion concentration and hydroxide ion concentration. So ionization constant of water, it is equal to the hydrogen ion and hydroxide ion concentration. Now taking the minus log on both sides, we have minus log of H ion. We know that in log term, when the terms are multiplied, we will put plus sign over there. Now here these both terms are multiplied, we will put plus sign. So minus log of H ion plus minus log of OH ion is equal to minus log of Kw. Now we know that minus log of hydrogen ion, it is equal to pH, plus will remain the same in formula, minus log of hydroxide ion, it is equal to pOH, and the minus log of Kw, it is equal to pKw. Now the Kw at 25 degrees C, the value is 10 to the power minus 14. And the pKw, by taking the minus log of 10 to the power minus 14, it will result 14. Hence pH plus pOH is equal to 14. In other words, the sum of pH and pOH is equal to 14 in water or any other aqueous system at 25 degrees C. Here the 25 degrees C is the optimum temperature for pH and pOH. If the temperature is increased or decreased than 25 degrees C, then the value of pKw and Kw will increase or decrease. Now we know that the value of pKw will decrease with increase in temperature, and the value of Kw will increase with increase in temperature.